continue with Chapter 3, Section 1 and 2, problem number 3. So Ginny knits 2 different capes. The Ginny model requires 3 hours of knitting and 7 hours to embellish the cape. The Helen model requires 5 hours of knitting and 5 hours to embellish the cape. Find the feasible solution graphically if Ginny has at most 60 hours a month to knit the capes and at most 100 hours a month to embellish the capes. List the corner points of the feasible region. So here let X represent the Ginny models and Y represent the Helen model. Using the information above, it will yield these 2 systems of equations. So again, let's notice we have 3x. So the Ginny requires 3 hours of knitting, and the Helen requires 5 hours of knitting. And at most, this is at most, is less than or equal to 60 hours of knitting. So here we have our knitting inequality, and the second equality is our embellishing inequality. So the Ginny model requires 7 hours to embellish. So we have 7 hours to embellish the Ginny model. And we have 5 hours to embellish the Helen model. So we have 5 hours to embellish the Helen model. Again, at most is less than or equal to. And we have 100 hours to embellish the capes. So again, at most is less than or equal to 100, and this is your embellishing inequality. So again, you need the x is greater than 0 and the y is greater than 0. So we have that. Now let's draw our lines. So we have 3x plus 5y is equal to 60. So we're going to let x is equal to 0 and solve for y. So we have 3 times 0 plus 5y is equal to 60. So 5y is equal to 60. Divide both sides by 5. Y is equal to 12. So here we have x is 0 and y is 12. That is this point right here. This is y is equal to 12. And now we're going to do the same, but let's let y equal 0. And let's solve for x. So we substitute 0 into the y. So 3x is equal to 60. Divide by 3. We have x is equal to 20. And this is the 20. So y is equal to 12, and x is equal to 20. And we have a solid line again because it's less than or equal to. So they're both going to be solid lines. And using our point of testing, let's use 0, 0. Since 0, 0 is not a point on the line, so we substitute 0 for the x and 0 for the y. So we have 0 is less than or equal to 60. That is true. So we're going to shade below. And that completes the first line. Now let's do the second line. So we have 7x plus 5y is equal to 100. So let's let x is equal to 0 and solve for y. So we have 7 times 0 plus 5y equals to 100. So solving for y, y is equal to 100 divided by 5 is equal to 20. So y is equal to 20, and that is this point right here. So y is equal to 20. And now let's let y equal to 0 and solve for x. So we have 7x plus 5 times 0 equals 100. 7x equals to 100. Divide both sides by 7. We have x is equal to 14.3, and 14.3 is about there. So 14.3, so let's draw that line. Y is 20, x is 14.3, again a solid line. And let's use a test point. 7 times 0 plus 5 times 0 is less than or equal to 100. 0 is less than or equal to 100, true. So we're shading below. So your feasible region is bounded by the following corners: 0, 0, 0, 12, point of intersection, and 14, 0.3. So here, to find our corner point, which is also our solution, let us use the elimination method. So let's use the elimination method to solve that point of intersection. So 7x plus 5y equals 100. So here, let's cancel the y. So if I cancel the y, I want to multiply that first equation by -1. So multiplying that by -1, I have negative 3x minus 5y is equal to -60. And add it to the second equation. Excuse me. That cancels the y. So I have -3 plus 7 is 4x. -60 plus 100 is 40. And dividing both sides by 4, I have 40 divided by 4, which is x is equal to 10. So now substituting that 10 back into the equation, plug it back into the first equation. I have 3x plus 5y is equal to 60. So 3 times 10 plus 5y is equal to 60. So I have 30 plus 5y is equal to 60. Subtract 30 from both sides and divide by 5. I have my y is equal to 6. So now I have all my corners. So my corner points are 0, 0, 0, 12, point of intersection, which we just calculated, 10, 6. And the last point is the y-intercept, 14.30. And these are my 4 corner points in my graph and my feasible region. And this completes Chapter 3, Section 1 and 2.